Okay, in this chapter, chapter 10, we're going to talk about comparing either one group, a, a single group to itself, or two groups. Um, the first one that we're going to look at is called a one sample t-test. And then basically, this is where you take a group, for example, like the class that you're in right now, we could take that group and compare it to some kind of national norm. So if I had a group of people, then I had the IQ test scores. If I wanted to know, for example, does my group of people, are they significantly different than what is considered to be the national average? The national average is for an IQ is 100. So I would look at my group, enter the national average for that, and you could compare them to any average. I'm just putting that in as an example. And what we're saying in terms of a null hypothesis is that there is no significant difference between my group and what is considered to be the average for the national group of people who have taken the IQ test. So I want to see if I can reject that null hypothesis. And what you're going to come across is something that looks like this when you're reading your research articles. You'll have a t-score with a number, something called a degree of freedom. It is abbreviated DF with the number here, and a p-value. And basically what this means, the most important thing that you need to look at is one is this t-score, because that tells you it's a t-test, and this p-value. If you remember, we want the p-value to be less than 0.05. And what that means is can be sure that 2.5 times out of 100 we probably made a mistake. Another way to look at that is less than 5 times out of 100 we've made a mistake. So that means 97.5% of the time the difference that we're seeing is because there really is a difference. There are several types of tests that can be conducted with t-tests. And they're given different words, but they basically mean the same thing. There is something called paired, dependent, matched, or within samples test. These all mean the same thing. And basically, the most common type that we'll see is where you have one group, you give them some sort of treatment, and then you give them you have one group where you give them a test, provide some sort of treatment, and then you give them another test. So that is one group with two tests. That's sometimes called paired, sometimes called dependent. An independent sample or between sample is where we have two groups with one test. So we're comparing males and females, for example. Either way, with a t-test, you can only compare two things. You cannot do multiple t-tests. You can't say, I want to compare the freshmen to the sophomores to the juniors to the seniors, because every time we do a test, we have a chance that we have a little bit of error. The error is in here. The error is the chance that we might have said something that's true that's not. On matched samples, sometimes you'll come across the easiest example to give you is spouses, where you're asking a question of a man or a husband and a wife, and you're seeing if there's a difference between how they perceive things. That's a pretty simple one to see. Sometimes people try to do matched samples, but the problem with a matched sample, it is often very, very difficult to make sure that there's nothing else different between them. If they only differ in one variable, like the difference is does the male counterpart in a marriage see things differently than the female counterpart? Just to try to match people up is very, very difficult to do because there's so many other things within people that can cause the differences that we're seeing. As I said, you can only do t-tests between groups, two groups. You can take several attributes. For example, if you're comparing men and women, and you want to compare their attitudes towards football, and then you want to compare their attitudes towards shopping, and then their attitudes towards cooking, and then their attitudes towards finances. Those are multiple tests, but you're not having multiple groups. It's one male group, one female group that you're testing on multiple examples. The degrees of freedom and the degrees of freedom are basically part of the statistical analysis that are being used. Can give you a clue as to how many people are in the study. And I'm going to refer you to page 220 in the textbook. If you look at that, it's an example of a set of t-tests where we have males and females, age distributions, etc. So if we look at the first one where we have 56 males and 43 females, that means we have 99 participants. If you look over to the right, there's a t-test over there. A couple things we need to notice is one is there is a t-score that's 3.105. It has a DF, degrees of freedom, and that means that is 97. And then we have a p-value. The p-value is less than 0.05. So there is a significant difference between males and females on this SAST score, with the males scoring higher than the females. And you also notice it gives you a standard deviation. On the degrees of freedom, what I want you to notice is it is 2 less than the total number of participants. And the reason why is because some of the data is taken out. And as a matter of fact, one piece of data from each group is taken out. And that's where the degrees of freedom comes from. The degrees of freedom is how much data is allowed to fluctuate. And it'll let everything except for one piece out of each group fluctuate. So one of the things you can tell that's happening is to what extent they're using all of the data that's available. One of the things I want you to remember is that researchers are making a hypothesis about the difference between populations. So looking back at this example on this table, they have a sample of 99 people with a degrees of freedom of 97. They are not just talking about the males and the females in this study. They are using that data with what they consider to be good sampling, I suppose, to make an estimate about a population that sample was taken from. And this goes back to the chapter about sampling, about why we have to have really good samples and why you need to be able to read research articles to try to determine what population they're trying to generalize to. You have an example of an article. This is an article about geography, and there's going to be a discussion thread about this. And basically what they're doing in this is they're analyzing achievement scores on geography and some other attributes, for example, male and female. So just to look at an example of an article, let's look at this first hypothesis. There is no significant difference in the achievement of male and female students in practical geography. So there's an example of something that can be done with the t-test because there's 2 groups, male and female. There's no significant difference in the practical geography achievement of students offering science and commercial subjects. Again, 2 groups. Now here, hypothesis number 3, we have low, medium, and high numerical ability. Now we have 3 groups. We can't do that with the t-test. So if we scroll down and find an example of the data analysis. In table 1, what I want you to notice is there's 367 people. Here is the mean of the males on their practical geography score and the females. There's a degrees of freedom. Now, remember what I said was you take one away from each group. So if we have 367 participants, our degrees of freedom should be 365. The question is, why is that being reduced? Incidentally, we could say that as far as we know, there is no significant difference between the males and the females, because this value over here is not less than 0.05. Here is an example where all the degrees of freedom are left in. 365, we took one from each group. This does have a significant difference in those who were in science scored higher than those who were in commercial. So you have a few discussion questions about that. But going back to what is happening with the practical geography, the challenge with statistical tests is if you're going to compare, for example, in that group, the males and the females, the data kind of needs to be distributed evenly. If it's not distributed evenly, you can't very well determine whether or not there's a significant difference. We talked a little bit at the beginning of the course about skewness in terms of having a positive skew or a negative skew. What we need is if we're going to compare the males and the females in that geography study, the male group needs to look like this and the female group needs to look like this. Or the male group needs to look like this and the female group needs to look like this. The challenge is we've got to have both groups distributed evenly, because we don't want one group that looks like this and one group that looks like this, because we have a few people that are skewing the distribution of the data. So what happens in an example like the geography, where we have a reduced degree of freedom, is that they are cutting off the top end of the scores, so that you end up with two sets of scores that look similar. This is something that happens with a test called Levene's test of homogeneity, and it is a way of ensuring the researchers and ensuring the person reading the article that there isn't any kind of skewness in the results. By lowering the degrees of freedom, we're forcing the computer to be more sure that there's a difference, and that difference can be attributed to the treatment and not the sample we chose. We don't want, because our sample looks like this, to be the variable that influences whether or not we're seeing a significant difference. We want to make sure that it's really because of whatever it is that we are doing to the group. So you need to go to the discussion thread associated with this. There's going to be two discussion threads. One will be about the geography paper, where you'll read the paper and answer a few questions, and the other one will be about just some real short examples of matched and independent pairs.